So now we're going to apply the mean value theorem and the intermediate value theorems to a real world example. It's a very important real world example. It's a pot of tea cooling. So this chart shows various temperatures taken as a pot of tea cools, and it's modeled by a differentiable function, h, where these are the temperatures and these are the times. So the first part A, use the data in the table to approximate the rate derivative at which the temperature of the tea is changing. So the rate at which H is changing at 3.5. So you will notice that 3.5 is not on the chart. So we do have to approximate it. Well, it is a derivative. So a derivative can be approximated by a slope. So since 3.5 is right here somewhere between 2 and 5, if we take the slope between 2 and 5, so y2 minus y1 over x2 minus x1, that would be an approximation of the derivative of anything between 2 and 5. So h of t is the y value. So we're going to have 52 minus 60 divided by 5 minus 2, which is a negative 8 over 3. So a couple things about that. That is a negative rate. That makes sense because the temperature is decreasing. We learned that already. And also the units. The units up top would be the units of H, degrees Celsius. Over the units on the bottom is the T's, minutes. So that is a rate. Remember, unit per time. So that's how you estimate a derivative. And that's what B asks. So I would pause this and see if you can estimate H prime of 7. And then check it with my work that I'm going to do right now. So it says estimate H prime of 7. And more or less, it's the same thing we just did up here. Same thing we did. What we did up here was we estimated H prime of 3.5. So we'll do the same thing. 7 is somewhere in here. So we're going to find the slope between these 2 points. y2 minus y1 over x2 minus x1. And that would be negative 8 over 4, which is negative 2. Now, ask a couple other things. Units and what does it mean? So I like to do units first because that will help us with what it means. The top is degrees Celsius. The bottom is minutes. So a negative 2 degrees Celsius per minute. That's a rate. So we would say this approximates the rate at which the temperature is decreasing because of a negative at t equals 7. So again, in the context of the problem, this is the approximate rate that the temperature is decreasing at t equals 7. Next question. Is there any time that the temperature in the pot is 50.443 degrees Celsius? Strange number, but we'll figure that out. That's a value. So without using calculus, if you just look at this table, you could ask probably a third grader this question. It goes from 66 to 60 to 52 to 44. Of course, it has to hit 50.443, you would think. And when? Well, somewhere in this area. So I'm going to answer the question. I'm going to say yes between t equals 5 and t equals 9. But that's not good enough. You can't just say, well, of course it's going to do that. What if for some reason the temperature goes from 50 goes to 51 and then jumps right to 50 and never hits this? You would say, well, it can't do that. And you would be right, but we're math people here. We need a way to prove this. And here's the proof. This function is differentiable. And differentiability implies continuity. So we know this function is continuous. For any continuous function, the intermediate value theorem applies, which means every value between value A and value B must be reached as long as your function's continuous. That's so important. It has to be continuous. So our explanation is a valid one. It's the IVT. Finally, because we're going to skip B. It's kind of a dumb question. Is there any time when the temperature is decreasing at a rate? So now we're talking about rate of exactly 2 degrees Celsius per minute. Explain. So is there any time that the temperature is exactly, this is a rate. Exactly would mean a derivative. Derivative means the change at a single point. So it's really asking, is there any time that the derivative is 2? Well, look at this. We know that the average slope, this is not a derivative, but it's an average somewhere, is 2. -2, but it's decreasing, so that's okay. So that does mean there has to be some time that it actually equals -2. The reason? Well, what we were just going over, the mean value theorem. The mean value theorem says if your function's continuous and differentiable, well, it says it's differentiable, so that's important. And differentiability implies continuity, so it is continuous. Therefore, the mean value theorem applies. The mean value theorem says there has to be a derivative at C that equals the rate of change at C. So you don't have to write all this down, but I want to show you what I'm comparing it to. So this is saying there has to be a derivative somewhere between this time and this time that equals -2. So we're going to say between t equals 9. Oops. T equals 5 and 9. So that may be a little bit confusing. Watch it again, ask questions, and we'll have some practice with that as well. So thanks for watching.